Hello guys, this is Ishan Akbar. In this video lecture, we will discuss a new problem about the hydraulic jump. So this is the statement of the problem that we have a rectangular channel in which there is a discharge of 5 meter cube per second per unit width of the channel and the approaching depth is 0.6 meters. So if we write the data that we have Q, the small q discharge intensity, because the in statement you can see here that a discharge of 5 meter cube per second per unit width mean this is discharge divided by B. This is known as the discharge intensity. So we can say that this is given as Q by B, which is equal to 5 meter cube per second per meter width of the channel. And the approaching depth mean before the creation of hydraulic jump, the depth of flow is 0.6 meter. Classify the hydraulic jump type. We have five types of jump. First type is angular jump. The second type is weak jump. The third type is oscillating. The fourth type is steady jump. And the last one is strong jump. So we can classify the jumps according to Froude number at section 1. Mean if this is the bed of the channel and this is the jump region, so this will be section 1 and this will be section 2. At section 1 Froude number will be F1 and at section 2 Froude number will be F2. So depending upon the Froude number at section 1 F1, we can classify the jump in five categories. So if Froude number F1 is between 1 and 1.7, mean greater than 1 and less than 1.7, the jump will be undular. If Froude number at section 1 is from 1.7 to 2.5, the jump is weak. And if its value is from 2.5 to 4.5, it's oscillating jump. From 4.5 to 9, the jump is steady. And if the Froude number at section 1 is greater than 9, the jump will be strong. So we have to choose one category of the jump according to Froude number in this question, because we have to classify the type of the jump either weak, oscillating, steady or strong based on the Froude number. So you always need to calculate the Froude number at section 1, mean we will need to calculate F1 at section 1 to classify the jump either weak, oscillating, steady or strong. So for this we need to calculate, we need to remember the formula for the Froude number for a rectangular channel, which is V1 over G Y1 square root. From this question, we have Y1 with us, that is 0.6 meter, but we don't have V1. To calculate V1, we simply need to divide this Q by Y1. Why? Because we know that Q is equal to AV, or you can say A1 V1, and Q is equal to by1 v1 because width of the channel remains constant when a hydraulic jump is created. So if we divide these both terms on the left hand q over by1, we will get the value of v1. We have already the value of q over b in discharge intensity. So we just need to divide the y1 with this term, mean with this answer. It means that if we divide q by y1, we will simply get the value of velocity. So what is q in our case? It is 5 and y1 is 0.6. If 5 is divided by 0.6, the answer is 8.33 meters per second. So the velocity at section 1 with a discharge of 5 meter cube per second per unit width and a depth of 0.6 is 8.333 meter per second. Now we have velocity of the flow and depth of flow as well. We'll simply put down the values in the formula. 8.333 divided by 9.81 multiplied by 0.6 meters. So what is the value of Froude number here? and we will compare this value of Froude number with the values ranged on the right for the classification of the hydraulic jump. So the value of Froude number comes to be 3.43, 3.43. So the first confirmation is that hydraulic jump will be formed. Yes, hydraulic jump will be formed because there are chances for the creation of hydraulic jump because the Froude's number at section 1 is greater than 1, so the flow is supercritical. Now the second question is that what is the classification? What is the type of the jump? Because we need to classify the jump as weak, undular, or anyone. So the type is angular jump is between 1 to 1.7, weak jump is 1.7 to 2.5, and oscillating jump occurs when the Froude number is from 2.5 to 4.5. As our Froude number comes in this range, so we can say that the jump created in our question or in this statement is the oscillating jump. So we can simply say that the jump created in this channel due to these flow characteristics given, these two characteristics, is oscillating jump. Simply, if the Froude number was in the range of 4.5 and 9, so the jump would have been steady. And if the Froude number was greater than 9, the jump would have been strong. And if the Froude number was in the range of 1.7 and 2.5, it would have been weak. And from 1 to 1.7, it would have been undular jump. But in our case, the Froude's number is 3.43, which is in the range of 2.5 to 4.5 in this list. So we can say that our jump is in the category of oscillating jump. Thank you very much. See you in the next video with a new problem. Take care. Allah Hafiz.